Hi everyone, welcome to GDC classes English. So the topic that we are going to talk about is our pharmaceutical emulsions. Likewise, suspensions. Emulsions are another yet important topic from your exam point of view. So today we are going to discuss about the basics of emulsions. What are the theories that have to be kept in mind? What are the terminologies that have to be kept in mind? As well as what are the identification tests for the types or different types of emulsion. So to begin with, firstly, I'll just write quickly the basic definition of emulsions, right? So as we know that suspensions and emulsions are a part of heterogeneous biphasic system. So they are they are stated as thermodynamically unstable mixtures, of two immiscible liquids, obviously which are a part of a biphasic system, which consists of actually two phases. One is your dispersed phase, which is generally referred as an internal phase, right? And the other one is your dispersion medium, which is generally referred as the external phase. So these are basically two ways to classify the dispersed phase and the dispersion medium as external or internal phase, right? So the dispersed phase is nothing but uniformly dispersed into the dispersion medium. So as I have mentioned, we should know that the size range of an emulsion ranges from 0.1 to 100 micrometers. I'll just write it here. Particle size ranges from 0.1 to 100 micrometer. Alright. So emulsion may be defined as a biphasic system, likewise I have mentioned, which consists of two immiscible liquids in which one of the phase, that is the dispersed phase, is uniformly dispersed into the dispersion other medium, which is known as the continuous phase, right? So these are the thermodynamically unstable system because of their size and such properties, due to which they can undergo a lot of instability issues, including the flocculation, the coalescence, the other issues, screaming, right? So there is phase separation that is possible with the emulsions, due to which they are referred to as thermodynamically unstable systems. So we have to add a suitable emulsifying agent which is required to stabilize the system. We'll be discussing about these instability issues in detail. Okay, so and a lot of questions that are asked are from actually the stability point of view, from in the emulsions only. So now we'll see what are the types of emulsions. Generally that we have seen, there are two types of emulsions. Generally we have seen that there are two types of emulsions, including the oil in water emulsion, right, or the water in oil emulsion. In oil in water emulsion, we know that there is a water in the continuous phase while the oil molecules are dispersed into it. These are the oil ones and this medium is the, suppose, water one. So the oil is dispersed into the water medium. In case of water in oil, the continuous phase, that is the dispersion medium, is the oily part and the water is dispersed into it, right? These are, suppose, your water. We have just seen such type of systems. Yet there are two other types which are referred to as multiple emulsions. In case of multiple emulsions, there exists two more types which are referred to as water in oil in water medium or oil in water in oil, right? So these type of emulsion I can show you. They look like some of this that is mentioned here. Firstly, the water in oil type that I have already shown you, or the oil in water type, where there is a water phase and the oil phase. Here it is water in oil type, in which the water is like, these are the water droplets, alright, and this is your oil phase. Okay, in case of oil in water types, we can see the oil molecule, the oil particles are dispersed into the water phase, right? In case of multiple emulsions, you can see very clearly there is the oil phase, then the water droplets are dispersed into it. Inside the water droplets you can see tiny oil droplets. So it becomes oil in water in oil emulsions. Similarly, there is another type, that is the water in oil in water emulsions. The continuous phase is the water, in which the oil globules are dispersed. Inside the oil globules you can see small water molecules, right? So that calls it for a water in oil in water type of emulsion, right? Generally what we see, that what is the basic utility of your emulsions, right? So their basic advantages based on your pharmaceutical applications that the emulsions bear, including that they are able to deliver the water insoluble drugs through the oral route, right? Second advantage, the second utility that we can talk about is that they can mask the obnoxious taste of your as such pharmaceutical ingredient, right? Third thing is that by administering the we can administer IV intravenous administration of the we can say lipid nutrients would be impossible unless they are formulated into an emulsion. All right, so there are such type of basic advantages that an emulsion is offers, but yet as we have mentioned that emulsions are thermodynamically unstable systems, so they require continuous monitoring of their particle size, their distribution. So while formulating an emulsion, we should keep a close check on the particle size, what kind of distribution it follows, what is the polydispersity index, right? There are a lot of parameters which will help you to judge the phase separation also. All right, so they are important from a practical point of view, right? But these things should be kept in mind. So there are certain, I'll just write few points about the formulation, right? So as I've mentioned, the control of particle size is really important for the sustained or targeted release formulation of emulsion if you wanted to make, right? So the formulation ingredients of emulsions, firstly it is the oil phase, right? I'm just writing in really brief that you should know. Second is your emulsifiers that are required for it, right? Third is your viscosity modifiers. I am just writing in brief. Next is your preservatives, right? Preservatives. And fifth is your antioxidants. Most commonly used antioxidants, if we talk about, are nothing but BHA and BHT. All right, these are some basic formulation parameters that you should know. Now we will talk about how can we identify the type of emulsion, followed by how we can judge about the instability issues in the emulsion. All these topics are really important from your exam point of view. Mark my words, students, this is a brief short class, so we'll cover it really quickly. So these are the 5 tests. Direct question can be asked, which of the following is not the test for the identification of emulsion? First is your dilution test, second is your conductivity test, third is your dye solubility test, fourth is your cobalt chloride test, fifth one is your fluorescence test, right? So these are 5 basic tests for the identification of emulsions. These are really important. This can help you identify if the emulsion is your oil in water type or water in oil type, right? So I'll be giving you a little brief about these tests. So the first test, as we can see, is the dilution test, right? Suppose this is an oil in water emulsion. All right, so if you dilute this emulsion with water, if this is oil in water, you remember oil in water emulsion in which the water was your continuous dispersion medium and the oil globules were dispersed into water. So if you add water to this, the emulsion is not going to break, there will be no phase change, then it will be the oil in water type emulsion. But if it is diluted with oil, definitely there is going to be a phase separation, definitely there is going to be a phase change, due to which it will be referred to as a water in oil emulsion, not oil in water. It will be a water in oil emulsion if there exists a phase change. Right? So if water is added to the oil in water emulsion, then there will be a no phase change. If oil is added to the this is oil in water only. Yes, I've wrongly mentioned. Yet again, I'll just tell you it in brief. This just states that if the main emulsion is your oil in water type, you will add water to it, there will be no phase change. If you add oil to the same oil in water emulsion, it was oil in water only, then there will be a phase change. You can see there is a different layer of oil and there is a different layer of water, right? There will be phase separation. Okay. Next is your conductivity test. Again, very important. Now you can see, in case of conductivity test, there is a bulb that will be used as an indicator if it will glow or if it will not glow. We know that water is a good conductor of electricity and oil is not a good conductor of electricity. So based on this basic principle, if the emulsion will be oil in water type, we know the quantity of water obviously in the dispersion medium is more, due to which the bulb will automatically glow, because the water is your good conductor of electricity. But here you can see this is a beaker dipped with the electrodes, right, and connected with the bulb. The emulsion, the solution that is taken is your water in oil type. When the electrodes are dipped into the water in oil emulsion, the bulb will not glow, because the oil which is in the dispersion medium is not the good conductor of electricity. So by this way, basic conductivity test can be conducted just to get an idea of what type of emulsion. Is it oil in water type or is it water in oil type emulsion? Alright students, right, let's move on to the next. Yes, as I have mentioned, water is a good conductor of electricity, whereas oil is a non-conductor. So therefore, the continuous phase water runs the electricity than the oil. Okay. Next comes up with the fluorescence test. For the fluorescence test, dye test, you must know what are the water soluble dyes. I'll just write it here. Direct question students, these are asked from this point. You must know what are the water soluble dyes, which will, if your dispersion medium will be water, they will cover up the water part. Likewise, here you can see it is a oil in water type emulsion, where the oil droplets are dispersed into the water. If you will use a water soluble dye, then the dispersion medium will get colored. But if you will use the water in oil type of emulsion, in this case, if you will use the oil, suppose in this case if you will use the water soluble dye, only the water droplets will get covered. So you will understand if the dispersion medium is getting colored, then it will using, you must keep in mind what type of dye you are using. If it is a water soluble dye and the dispersion medium gets colored, it will be oil in water type. If you are using water soluble dye and the dispersion medium is as such, but there are small globules, colored globules, then it will be a water in oil type emulsion. Okay, so you must know the example of water soluble dyes, which are amaranth dye, which is indicated here red color, and methylene blue dye. Direct question will be asked students, right? Other one is your oil soluble dyes, which will provide color to the oil phase, even if it is in dispersed phase or if it is in dispersion medium, right? The two example for this is the scarlet red. The other one will be Sudan 3. Very important students, please note it down. Direct question can be asked. So by this way, by the change of color, you can also detect the type of emulsion, right? Next comes up your cobalt chloride test. Last but another important test. you can see here it is written that if you will take a filter paper that is soaked in the cobalt chloride solution, alright, and allow it to dry, it will turn from blue to pink on exposure to an emulsion. I'll just tell you in really quick brief manner. We know that the anhydrous form of cobalt is blue in color, but if it gets into the hydrous form, it will turn pink color. Okay, so by dipping the cobalt chloride paper, if you dip it into emulsion, the emulsion will turn from blue to pink. That will indicate because it got the change in color was observed. It will be an oil in water type emulsion, right? It will not work if the emulsion is broken, if the emulsion shows instability or in the presence of electrolytes. So just so you let you know, the anhydrous form of cobalt is blue in color. The hydrous form of cobalt will be red or pink in color as seen in this. So this is your anhydrous form. You take the paper of cobalt, right, this is your anhydrous form, dipped it into cobalt chloride, right. Then the anhydrous form, which is blue in color, if it is dipped then into the emulsion, the emulsion will turn color from blue to pink. This will be your oil in water type emulsion. So by this simple test, you can identify the type of emulsion. Alright students? Okay. So the next topic that we are going to talk about is your instability of emulsions. Yet another important topic. As we have seen, because the particle size and the size distribution are very important parameters to talk in case of emulsions, because they have a tendency to form floccules, they have a tendency to form undergo phase inversion, they have a tendency to undergo coalescence, right, which will ultimately cause the emulsion to become unstable. Alright, so one by one we have to see. There are three types. You can see there is a flocculation, there is a phase inversion, and there is the coalescence, right. So I'll just tell you what are the points that are really important from an exam point of view. First, if we talk about the flocculation part, very important. Firstly, these instability types themselves are very important. In flocculation, there will be a reversible aggregation of droplets. There will be a reversible aggregation of the droplets, right, which will come closer and will stick. So the extent of flocculation again will depend upon the particle size, it will depend upon the charge and your viscosity of the dispersion medium. Very important point. Another important point was what? That the flocculation, in case of flocculation, it will be your reversible aggregation. So as I mentioned, the particle size, the viscosity and the charge. By controlling these three parameters, you can prevent these flocculation. Alright. Second is your creaming. Second is creaming. In case of creaming, the dispersed droplet or floccules will ultimately continue to either rise up or will rise downward, right. As you can see in the image, if the floccules tend to go upward, then there will be the upward creaming. If they will go downward, it will be known as the downward creaming, where they will tend to form the sediment, right. So what type of, generally based on the difference of their densities, it will go to the upward creaming or the downward creaming. So if they rise, it will be the upward creaming. If they sediment, it will be the downward creaming, only based on the type of the densities that they exhibit. But one important thing that you should not forget is that in case of creaming, the sedimentation, this rate is actually based on your one law that is again asked, that is the Stokes law for the sedimentation. Alright, based on the Stokes law, the rate of creaming is what? Rate of creaming is equal to d square rho s minus rho naught g upon 18 eta, right? So the d is the diameter of particles, right, in the dispersed phase. Alright, this rho s will be the density of dispersion medium, rho naught will be density of dispersed phase, alright, and eta will be definitely what? Viscosity, and g will be your acceleration due to gravity. Alright, so one point to be noted is that the rate of creaming, one point that out of it that is important, direct question have already been asked, rate of creaming will be directly proportional to the square of the diameter, right, which can be deduced from this equation, right. Another major point to note was that rate of creaming was inversely proportional to the viscosity. In case of highly viscous medium, the rate of creaming will be low, and in case of low viscous medium, the creaming will be faster. Rate of creaming is inversely proportional to the viscosity and directly proportional to the diameter. So the larger is the particle, more is the creaming, right. Third is your coalescence. You can see here it is mentioned, which will ultimately going to cause breaking of your emulsion. This is actually a growth process during which the emulsified particles are going to join together to form a layer. Alright, this will ultimately cause emulsion to break, and the important point to note here, out of every other type that we have studied, this is the irreversible conversion. Alright students, this is the most important point to note. Okay, last is your phase inversion. Phase inversion. In case of phase inversion, as we know that phase is going to inverse, that is the oil in water type emulsion will be ultimated to the water into oil type emulsion, right. So if we intend to prepare an oil in water type emulsion, but the final emulsion that came out to be is the water in oil type, that means some type of instability has been occurred in your emulsion. This could be due to some reasons, that could be due to the addition of electrolytes, that could be due to the change in your temperature or change in your phase volume ratio, you can say. So there are multiple factors due to which this can happen, but yes, these are some major reasons. The things to focus on is your law, in the rate of creaming, basically your coalescence, that is the irreversible thing, the flocculation. All these points, students, are really important from your exam point of view, and I hope you will read all of these, right. These important points that we have already talked, right. We have seen the identification test as the dye solubility test. One point more that we will see here is we have seen the water soluble dyes, the amaranth one or the methylene blue dye, the oil soluble dyes, right. We have seen the dilution test, we have seen the conductivity test, right. Another test is your creaming test. Okay students, again very important questions have already been asked, but yes, dobara it can be repeated again, right. So in case of the emulsion, in case of the downward creaming, it is observed that the type of emulsion is your water in oil type emulsion. In case the creaming is upward, it will be indicated that the emulsion is oil in water type emulsion. Students, very important test. We can see, we have seen the fluorescence one, we have seen the dilution test, dye solubility test, the conductivity test. Another one was your creaming test. Creaming we have seen, in case certainly there the creaming can be done upwards, the particles rise upwards, or it will be downwards, they will sediment based on the difference of their densities. The creaming can be upward. If it will be upward, it will be oil in water emulsion. If it will be downward, it will be a water in oil emulsion. I hope you had understood all the concept. These were really important from an exam point of view, and we'll be soon discussing the questions from this topic. But please make sure to revise these all of these topics that we have discussed. So thank you so much for today's session.